Okay. So how how was your week? Did you solve any problems? How was it?
Yeah, let me share screen. Could you allow me?
Yeah, sure. Sorry.
Okay, could you see my screen?
Yeah.
Right now? Okay. Yeah, so I solved like from first one to to the six of the recursive functions and
What about the complexities?
here
Yeah.
I didn't thought about this part, but I think it's ON.
Okay, no problem. So, do you have any questions about these problems?
No, actually, no question.
Okay.
Yeah.
So everything was easy. Were they easy?
Not very easy, but I have to learn. Sometimes I can't solve the problem the first time, so I had to see the solution. Then I try to write the solution by myself. Sometimes I can figure out directly. Sometimes I had to analyze other people's solution. Something like that.
Okay.
Mm.
You want to solve some other problem from the list, or you want to do the complexities, or what do you want to do? Or you have another problem you want to do from Leetcode?
I don't know. I think we can solve a problem probably. Mm.
Okay.
Because next week I have an important interview, but I have no any confidence I can pass the interview. It's LinkedIn's tech interview.
LinkedIn?
LinkedIn, yeah, Tuesday, which
Oh,
make me very pressured. Mm.
I see. Wish you the best of luck.
Yeah, and last week I also interviewed one of my favorite company. It's called Autodesk, but I performed very bad.
Sorry to hear that.
Yeah, but it's not a tech interview. It's just like a interview with the hiring manager.
Yeah.
Yeah, and he asked me a lot of behavior questions. But I feel because I didn't prepare a lot about the behavior questions, so I just feel very hard to answer his question.
I see.
Mm. Yeah, but I told him, yeah, I said I pretty like Autodesk because maybe because my background, I interested in like architect and design. So they are making a application that help people to make construction, especially in the architect field. So yeah, I told him, I just interested in this field, but that doesn't mean I can pass the interview, right?
I see. Yeah.
Yeah.
Okay.
Yeah, just share with you some my recent experience.
Mm-hmm.
Mm.
Okay. Do you would you like to answer the time and memory complexities for some questions before going to solving some other problem?
Okay.
Okay, you can start from the top.
You mean this one?
Yeah.
Time complexity. I think it's ON. Do you think it's correct?
Okay. Can you explain though? Write your explanation.
Okay. Uh, yeah, so because it's a recursion of binary search tree, so I think the solution for this question is to traverse every node in the binary search tree using recursion. So I had to iterate every node on the tree. And totally it should be the time complexity is based on how much nodes are iterated. So it should be ON.
Okay.
Mm.
That's correct. What
Correct?
about the memory complexity? Yeah, can you write just one sentence?
How could
Just
you answer this question?
how would I answer?
Uh-huh.
Well, I would say I would have to traverse the tree. I can use any like pre-order, in order, or post-order reversal. It doesn't
Mm,
matter. But I need to almost go over all the nodes,
okay.
which is the most straightforward question, O of n. But you can also, it depends on your solution, by the way. You can write a solution that's log n, but it's fine. Here, what I want is, I don't want you
Mm,
to necessarily write an optimized version, of the code.
okay. But could you mention a little bit how could I get like log and time complexity? What kind of solution I use?
Well, the thing is that in the definition of a binary search tree, we don't have duplicates, but it's fine. I can make it just like this in a binary tree. It doesn't have to be necessarily binary search tree. And your answer would be correct like this. It's fine. It's fine. As I said, what I want is I
Mm,
want to see how the function is made, not necessarily. It doesn't have to be optimal. So I'm gonna check the solution.
so you think you mean the different as because it's a binary tree or search? Oh no, it's same thing, right? Binary tree and binary search tree.
No, if it was for BST, you either have the node or don't have the node. That's it.
Okay.
And you can find the node in log of n, right?
Mm,
Because it's a
mm.
binary search tree. You can either go left or go right. That's it. But on log n in the best cases, but I would say O of h if it was for BST. O of h, which is where h is the line of the tree. Which is in log n and best case log n, worst case n.
Where is
Yeah, but I checked the solution. It's correct. This is what I need from you. I need that recursive function to do this. Okay, what about memory complexity?
memory complexity is log n.
Okay, can you write it down and write your explanation?
Okay. Log and yeah, can write in this way. What do you think? Okay. Do you need I make an explanation?
Yeah,
For
of
the
course.
okay. Yeah, because when I traverse the binary tree, I have to use either call stack or my own stack. So every time when I iterate the nodes from top to the bottom, is like I put all of the nodes inside a stack. Is last thing, first out, data structure, like so for every how to say so I just had to analyze the height of the binary tree is that's mean how much nodes are stored in the stack. Uh, so yeah, it should be a log n layers. So that's also the memory complexity.
The answer is correct, but why are you assuming that the binary search tree is balanced? It's log n if it's balanced. Why are you assuming that it's balanced?
It's balanced. Let me think about.
Because it might be balanced and it might not be balanced. Can I have control
Yeah,
over your
you
screen?
yeah, I see. I know what you mean. But I mean it's like a can I say it's a worst case because if it's not a balanced tree, uh I just take the like I just take the highest direction like left or right. So even though it's unbalanced tree, I use its worst case is login.
No, it's not the worst case.
No. Uh-huh.
This is a binary search tree. So if you create, this is a balanced example.
Okay, it's a balanced tree. A balanced trees mean like the left and right layers. Uh, they don't have to be totally same, but they cannot. Like the different cannot more than one layer, right?
Yeah, exactly. For
Mm.
each subtree, not just tree, each subtree also.
Okay.
Because this is a tree. Like for example, the root 41 is the root of the whole tree. But the rule also applies, the balance rule applies on each subtree, the right subtree and the left subtree. The
Mm,
balance doesn't is at most one for each subtree.
okay.
Okay. What about this example? So if you run a recursion on this tree, what would be the memory complexity?
It's 5.
Sorry?
It is 5.
Yeah. So is it log n?
It's for what?
Is it log n?
Oh, login. Yeah, I think it's login.
Really?
Uh,
What's n? Yeah, what's n?
and it's the totally number of nodes.
Yeah. And how many total number of nodes we have?
And here is ON.
Jane, just can you give me a minute? Just I'll be
Yeah,
right
yeah,
back. Yeah, even less than a minute.
no problem.
Okay, I'm here.
Okay.
So, what is n here, and what is log n?
It's ON. It's
Yeah,
not
it's on exactly. Why is that?
because it's totally number of the nodes is N,
Mhm.
and but it only have one branch, scope branch, right? And and I only had to iterate this branch, and the total number is N. So so in this case is ON. But I feel it's like a worst case of the tree, right? Because
Yeah,
it only
yeah. It is the worst case, but that's what you should consider.
so yeah, so back to your last question. I think it probably should like ON to log in to ON
Yeah,
is
exactly.
on the structure of the tree.
Yeah. Is it, do you mean something like this?
What was that? Let me see. It was for BS2. Okay. It's a tips.
Sorry?
Is it what was that? Is it like a tip, right? It's a note. It's a comment.
Oh, yeah, yeah. It's a comment, yeah.
Okay. Mm,
It's a comment on this one,
I
on
see.
this. It's highlighted, you see? When you click here, it doesn't show, but this is highlighted because this is the comment on
Mm,
this. Okay, so the answer here is O of H, which is the height of the tree.
okay. So you think if the like what's the name is reviewer ask me this question,
Mm-hmm.
do you think I should tell him like all of the situation of the tree, how I analyze the structure of the tree to get the um, possibility of memory complexity, or just
Yeah, yeah, yeah. It's actually not complicated. You can. It's all mentioned in here. So what you can mention, you say it's so. when you talk about memory complexity, you should say it's O of H, where H, sorry, I cannot tell you.
You can
Where,
you
yeah,
can click shift to fix this.
okay.
Mm.
Where H is the height of the tree, which is in log n n.
Okay. So you mean if he asked me the memory complexity, I had to tell him the totally like the whole process, how I analyze get this result instead of just tell him the just the find like I
Yeah,
just tell him login.
yeah,
Okay.
log n if it's balanced, and n case if it's skewed. And it can also be in between, because it can start off as a balanced tree, but not necessarily the worst case. But it can
Okay.
be a non-balanced tree, but not necessarily very optimized and log n. You see, it's a range. It's a whole range between log n and n. Log n is the best case, and O of n is the best worst case. Sorry.
It's worst case.
Yeah.
Okay.
Okay. Let's go next. First for the code of this one, number of paths from a root till the end.
Unique path, unique path.
Yeah. So what I mean by this is, like you see here, uh, so here the number of unique paths from 41 to 11 to 32 to 50, 72, 99. So we have 5 examples.
Mm-hmm.
So that's the answer. The path is from the root till the end, or till we find a leaf. And I check your solution. Your code is very similar. This code is very similar to this code.
Yeah,
But no, that's not what the problem asks you to do.
really? Let me see the question.
Yeah.
Unique path. Um, you mean the solution is not correct, or you think I should use different way to solve this problem?
Um, a fruit dot now. No. Thing is that here you have to count the paths. And the first problem, you count the frequencies. So if you have 29 in the first example, you should return 1.
Okay, wait me a second. Wait me a second. Let me
Sure.
see.
But in the second example, you have to return 5.
I think it's different. It's a different one. Mhm. Okay, that's different. I think I put a different one. Let me find out. Okay, wait me seconds. Okay. Can you see my screen?
Yeah, I can see your screen.
Yeah, I think I put a different one on the GitHub. It should be this one.
Oh,
Yeah.
okay. Yeah, it's actually that one. Okay, but
Mm,
it's correct. But can you change it and make it return the result instead? I don't want you to use paths. I want you to remove this variable
let me
and
see.
return the result within one function. So here you do find unique path. Okay, I want you to remove this
Mm,
DFS and use one function without paths variable.
okay, let me try.
Okay.
Okay, I think it's like
Mm,
written. Yeah,
yes,
it's
correct.
correct.
Nice,
Okay.
nice. Yeah. Can you copy paste it on your GitHub?
Mhm. Okay.
Mm-hmm. Okay, it's the second one.
Yeah, I'm gonna upload later.
Okay,
Mm,
sure.
but, yeah, a lot of it is wrong actually. It, but I think that's fine because the two is should be three and three should be four.
Oh, okay. Because I'm checking the solutions. Anyway, you can answer the time and memory complexity.
Okay, here I think it's on time complexity because it's also I have to like iterate every nodes in this binary search tree. So the totally time complexity should be on because they are yeah, the end
Yeah,
nodes binary search tree.
yeah, right. Correct. Yeah, you can like write the answer and just write a sentence or two to describe why use it like that.
This one. You may write a description, right?
Yeah, just a sentence or two, yeah, not something, very long.
No, it's correct. It's wrong. No, okay. Don't let me write English. I'm not good at writing English. Yeah. No, okay. It should be how E.
Okay. You know what? Let's just answer them orally, and I'll let you write down the answers later if you want.
Okay.
I want to make sure that you know the answers. So yeah, okay. What is the here time and memory complexity for this one, this solution?
Uh, you mean the third one?
Yeah.
To find the subsets of array of integers.
Mm,
I'm thinking about.
okay.
mm, it's n squared.
N squared. Is
Mm,
that the time complexity?
yeah, I feel it's like n squared.
Why is it n squared?
Uh, because I'm imagining the process is still like a tree, and like every layer is uh 2n nodes. The first layer is 0, and the second layer is 2 nodes, and third is 4 nodes. So the last layer it should be n squared. And from 0 plus 1 to 2, 4, 8, and to the last layer, uh, n squared is totally it should be n squared.
No, it's not.
Do you think it's correct or wrong?
No,
The
no,
answer?
it's not correct.
Okay. Eh, let me see subsets of array in integers. I don't know how you analyze this time complexity.
Well, to understand this, you should try to imagine all the scenarios that come up to create the all the subsets of arrays of integers.
Mm.
Your answer is actually correct. Check the code. Uh, I don't have access anymore, by the way.
You mean the answer is correct? You mean the code is correct, right?
Yeah,
Okay.
the code is correct. So it goes like this.
Mm.
You at each recursion, you create two scenarios. Like remember, this is a recursive function,
Mm.
and look how it looks like. You have what is your depth and what is your branching factor. Do you remember when we talked about this?
Uh, say again your question.
I said, do you remember when we talked about the branching factor and the depth of a recursive function?
I yeah, that's
Yeah. Um, I think we have talked, I'm not sure, but I think we have talked about this. There are a lot of recursive functions look like time complexity is O of branching factor
shift. Okay, try.
to the depth. Branching factor is how many at each of how many branches do we open? Depth,
What's
how,
what's OPFH called? How many branches do we have?
and for our case, this case, that formula applies. So what you need to do is to find out what is the branching factor. So here, what do you see? What is the branching factor?
Mm, can you go back to the comments? Let me see again your comments.
This one?
Yeah. And I think the depth should be the number of the character. Let me see.
Yes, you're right. Yeah.
Mm, depth and every uh every layer should be two square. two to the n.
Yes, yes, exactly.
Mm.
Do you understand how it is 2 to the n?
To the n. You mean totally?
Yeah, yeah. The complexity is 2 to the n. Yeah, as you mentioned. I mean, your answer is correct because you have, let's say, you have your answer is A, B, C. So at the start, for A, you either take it or not take it. So it's like A 0 and A1.
Yeah,
Where,
choose
yeah.
the one.
Then two branches are created. For B0
Mm.
and B1. B0 means take B and not take B or not take B. So here, for example, the string is B because we didn't take A but took B.
Mm.
Here B0 and B1. And here the string is AB because we took both A and B. Here A but didn't take B. Here we took none. Clear?
Mm.
And same thing for the last layer. Last layer um, goes the same thing. Same thing is repeated with C. So C0, C1, C0, C1. Clear?
Mm. So the last layer should be have two to the n nodes.
Yeah, it's always like here you start from empty string, and then from this empty string we create this branch, and this branch.
Okay. So what's the totally time complex? It just it's depend the last layer, right? The last layer is to the n,
Yeah,
and
it's
from 0 plus 2 to the 2 to the n is totally is to
yeah.
is
So here we have a root, and then we have two nodes here,
mm,
and then we have four nodes here, and eight nodes here. You see, it's always multiplied by two.
yeah.
Yes,
So it
that's
should be 2 to the n, right?
yeah, yeah, correct, correct. It's to the end, and we keep doing this. Like, look, for each layer is a character. That's why the depth is n. So our string is ABC. So we have three characters, and for each character, we have a layer. This is for A, this is for B, this is for C. You see?
Mm.
And actually, goes like it keeps going. C,
Yeah, I got your point.
yeah. And for example, like A0, B, like here, the string will be BC.
Okay.
See, each
Yeah, I think I understand this
Cool.
process.
Cool, cool.
Mm,
Okay, so can you write some two sentences, then describe how it goes? Like
uh,
here.
okay. Let's see.
Every layer is to the end.
Uh, right? Mm, yeah, the N is yeah, it's the current number of the layer. That should be see.
Well, it's actually correct. It's correct.
Okay.
Okay. Um. Okay. Are
Wait
you
me a
done?
second. I'm going to take some drink.
Okay.
Okay, back.
Welcome back.
Okay, next question.
Yeah, you can explain the memory complexity here. I'll write some comment here.
Hmm. Does English is your native language?
Oh, it's my third language.
Huh?
It's my third language.
Uh, you said
Third.
secondary language.
No, third language.
Third language.
Yeah,
Oh my. What was your uh second language and
French.
first?
First is Arabic.
Is Tunisia.
Yeah, I'm from here.
Okay, it's your first language. So what is your second language?
Second is French because we were colonized by France, you see.
Ah,
So 1956, independence from France. But we still learn French as a second
okay.
language.
So you can say French very well, right?
Yeah, yeah, I speak fluent French.
Mm.
Sorry about this.
Uh,
Let's go to the end.
I still cannot say the English very well. You know, right now it's every day. I feel I have to spend a lot of energy and time making phone call with recruiters because my English is not very good. I had to pretend I can speak, yeah, pretty fluent.
I personally understand you. I have no issues to understand you, to be honest.
Oh, I see.
I had some Chinese colleagues and the ex and when I in my previous company, so they taught me a bit of Chinese words.
Uh,
It was fun. Like I can say ni hao, what's up, yo, wo chao, dia, nian.
oh, yeah, yeah, yeah. Mm, this is pretty better.
And in our case, we have two as branching factor because at each recursive call we either take or factor
What was
n layers.
And you know, it's very ridiculous because we learn English for many, many years, but still cannot see English very well. I think
How long have you been staying in the US?
I just 2 years, actually not 2 years, just more than 1 year.
Oh, and then
Because
you're doing a very good job.
because I just came to here, finish my master degree. I just
Mhm.
got my master degree of art and technology, and yeah, actually, so that's why I'm currently actively looking for a job because I hold F1 visa and have 3 years OPT time in here. Yeah,
Mhm.
I have to find a full-time job within 1 year.
I
Uh,
see.
yeah, to extend my OPT. Hmm,
Cool.
pretty hard.
No, I think you can make it. 1 year is more than enough for you to find a job. Trust me.
Really.
Yeah.
Actually, next week I will start my internship. I accept the offer because I think I can begin from practice communication skills mm, by taking intern. But I told them I can only like work for 3 or 4 hours every day.
Oh, I see.
Mm.
And how long is the internship gonna last?
It's just in the contract it says 10 weeks.
Okay.
Yeah, but I thought once I found a full-time job, I just can end the
Oh,
contract.
okay,
Mm,
okay.
yeah,
I see.
go ahead, just share some experience with you. Okay.
So, what do you think about the memory complexity?
In here, um, memory complexity. It should be ON.
ON? Really?
ON.
Mm, how is it ON?
Because as we analyzed this tree, it has n layers. I mean, the depth is n, and that's also the numbers of the call stack. Um, yeah, the call stack. It should be have n elements in the call stack, so I think it should be on the memory complexity.
Okay. Hold on though. look at it. What about this? The result here and results. You're appending. Look,
Let me see the results. Okay. Is is an is an array and capacity. So it should be 2n.
yes, there's 2n because we have 2n strings or subsets,
Okay.
but each element is a string, and you need to take into consideration the length of the string. So it is O of 2 to the n times string. Because we have yeah, 2 to the n strings, but don't forget the length of the string,
Okay.
which is
Length of the
using
string.
n or it's
Why is 2 to the n?
because the length of the string goes up to n.
Let me think about why.
Because we have 2 to the n. Each string has
2 to the n strings and it's the last layer, right? Let me think about that.
like, for example, for ABC, your final result is going to be, okay, I'm not going to do the codes just to be faster. AB, AC, AB, ABC, right?
Okay, it should be 2 to the n numbers of results.
Yeah.
Me.
And we need to consider also the length.
Yeah, I'm thinking about, but I'm a little confused. I just thinking about what time I just thinking about the cost stack and what time I think about like the results I can get finally.
I don't understand.
I mean, do you need to think like the cost stack when you're thinking about the memory complexity?
Oh, yeah. This is not for the call stack because, yeah, I got it. I got your question. The thing is that yes, the call stack. So you said it's how much is it for the call stack? Can you answer here?
It's ON.
Yes, it is ON. Yeah, but the thing is that this is okay. So it's ON. because we have n layers. Okay, this is correct. But the thing is that the memory complexity is composed of two components.
Mm,
You see, there's the recursive function that generates that OM, but there's this array that generates a bigger number, and that's why.
okay, so it should be n plus to the n.
Yes, exactly.
But what's the final result if I see is n plus to the n?
Uh,
I don't have to think about the n, right? Because 2 to the n is much larger. No, probably,
it's
but
actually both of them. Actually, you're right, and it's both. So it goes like this plus n. The reason why it's because when you are at the end of the tree, let's say when you are here, or when you are at this point to be precise.
mm,
So when you are here, your call stack is at its maximum, and your array is also at its maximum. So it's n plus 2 to the n times n. But still, that number is way bigger, so you can allow yourself to ignore it. Yeah, it's,
I have a question.
yeah, sure. Go ahead.
Could you drop to the here? I can drop here. You mean when I at this node at C1 it is the maximum cost stack? Why?
Because you have, look, when you are at this layer, your stack has this, and this. That's why it's at its maximum. Whenever you are at this layer in the recursive call, your stack is at its maximum. You
But
always,
mm, yeah, I'm not very understand this part because before when I think about the cost stack, I think it's like from top to the bottom, from this one to here to
yes,
here,
yeah,
and to here. But when I reach to this zero, do you
yeah,
think it's also the minimum maximum of the cost stack?
yes, it is, it
It's
is.
also
Yeah, look, what happens is, so when you start here, then here, then here. But the thing is that when you move from here to here, this is popped. When you pop, it goes like this,
yeah,
and you
and I
push this.
put a new one, yeah.
Yes, this is how it goes.
So I
And
should see every time when I reach the bottom element, it should be the maximum of the cost stack.
exactly, at each element, here, all of them, because your layer, if look, for example, if you are here, your the stack has this and this. If you're here, your stack has this and this. If you are here, your stack has this and this. You always, your stack tracks everything that's from the root till your current state,
Mm,
and it's always the maximum is the number of layers. That's why it's the maximum number of layers, because it tracks the steps that you have took from the root till your current node.
mm,
Yeah.
okay, got it. Yeah.
Is it clear?
Uh,
Is it clear?
yeah, it's clear to me.
Okay. I have a follow-up question. So let's say that, okay, I personally did not ask you to store all the answers. So I only asked to find the subsets. So there are two scenarios. You can either store them all in the results, like append them all, or I
Mm.
can ask you to only print.
Only
If,
print.
yeah, without storing them. And so if you print the results, what do you think the memory complexity is going to be?
ON.
Why?
It's because I don't have to initialize the memory for storage all of the substrings, and I only need to account the call stack, and the call stack is ON, so the memory complexity should be ON.
Yeah, almost correct. But let me tell you one thing. This is a bit complicated, but bear with me and I'll try to explain. So, for example, here, when you are here,
Mm,
A B C, and after that goes A B C. Your call stack has A, then A B, then A B C. Remember, your stack, it has to store the whole thing, this and this. And here you have array.
mm. The array is input.
Yeah. And you have this array also.
Ah, subset.
Is this a
Subset. Let me see.
okay, what I want to say is for cases like this, you can store different lengths of the strings because your stack is gonna have um, a do you remember when we did the generate 0 1?
Mm.
Do you remember that exercise?
Generate 0 1. Could you see
Generate all strings of length n.
all strings?
Uh,
Oh, it's like combination of 0 and 1.
yeah, characters can be either. Do you remember that exercise?
Uh, yeah. I have some impression about this question.
Okay, so in that exercise, you have a buffer, which is like this one, and your buffer goes. You have 0, and then from 0 we create 0 1. Oh, no. I'm talking. What I'm doing here is the whole buffer.
Mm.
So it goes like this, and then this one goes like 0 0, and then 0 0 1, and this one 0 1 0 0 1 1. Is it clear how the branching goes?
Uh, can you see again what goes pressure? Could you see that word again?
Yeah, just 1 second. Okay, so this is the buffer.
Okay.
When you are here at this state, for example, you store everything that's behind you. You store this and this and this. Your buffer has to store buffer has to store length last layer. It has this plus this has strings of length 1 plus length 2 plus length 3 plus length layer minus 1. Is this clear? It's 1 plus 2 plus 3. Is it clear?
Yeah, I'm thinking about what's the meaning of the n? It's the totally number of the character, right? The n.
Yeah, of course, yeah.
Okay.
Is this sentence clear? Is it, you understand it?
Yeah.
Okay. So your stack will store all of these, which is n times n plus 1 over 2, which is O of n squared. So in a case like this, your buffer can have up to have up to n squared memory complexity. It's not, it's a detail. It's a bit confusing.
Yeah, I have a question
Yeah.
actually here. So why is 1 plus 2 to the n can get the n square?
Yeah, because
Uh,
look at the formula.
it's a mathematic formulation, right?
Yeah. It's a arithmetic sum.
Arithmetic sum. Okay. Oh, yeah, okay. I see.
Yeah. Anyway, you can consider it n. You don't have to consider it O of m, because in this example, because it depends, and it depends on how you write your code. If you make it a global variable, or you make it a or if you pass it by reference, then it's going to be O of n. If you create a new variable at each call, it's going to be n squared.
Well, what do you think for this case?
For this case, you either create a global variable for your buffer for this subset, or you pass it by reference. And it's going to go down to O of n for the call stack. Let me write this down. Okay, I'll write it from my computer. Okay, so uh, you know what? I'll write it and then I'll put it as a comment. So if we pass our buffer by reference or make it global, then
So I'm thinking about in that case, I use a reference buffer, right? So the complexity is not ON. Is it ON or not ON? I am a little confused. I'm thinking.
I'm explaining. All complexity comes to it's fine, Jing. It's not the most important thing to know about, but
Okay.
I'm mentioning it. You have it when you have some energy. You can read it.
Okay, sure.
Okay. I don't have much time left.
Mm.
So
Gonna go.
let's keep. I think I can do 15 minutes.
Okay.
Um,
How about we use the rest of time like rather solve a problem as a practice.
15 minutes. It's
15
not
minutes.
enough.
Uh,
This is actually important, Jing. I know that it took us some time, but this is important that we discuss all of this, the time
okay.
and memory complexity, because I need you to understand this very well. Because
Mm,
if you understand this very well, then you can do these dynamic programming exercises better.
mm,
You see,
mm,
this is
I
why
see.
I'm moving, like step by step, and I need you to understand, have like a solid foundation.
Mm,
But we could do together some problem. We have already done this one the previous time, I guess, right?
mm,
Yeah, so we can complete it. This is done here. When you do this, we have already done this, and this is not complicated. You can do it by yourself. So after this session, you can take an hour maybe to finish all of this. And then you can start out all these exercises. And here it gets more interesting with the
mm,
dynamic programming exercises.
okay.
Um, okay, so I think we should continue with these ones. Memory and time complexity, as usual.
Let me see to find the max nodes in a path from root to leaf. I think that's pretty similar with previous questions. It's still the time complexity should be ON.
Yeah, can you write the answers, please?
Okay. Okay, and to find the maximum nodes, uh, is login. Hmm.
Yeah, can you explain?
Yeah. So for the time complexity is I had to um traverse the whole tree and iterate every node in this binary search tree. So it's totally in elements in this tree. So the time complexity is based on how much nodes I traversed. So it should be ON. And the time complex, the memory complexity is um it's based on it's still is based on its call stack because it's a binary search tree, and I only had to think about the depth of the tree, and the depth of tree is the login. So I think it is login
It's not
memory.
always login.
Uh,
If it's balanced, it is login. But what makes you say that
yeah,
it's balanced?
yeah, it's the same with the first question, right? So
Yeah,
if
okay. Can you correct
it's
it then, please?
okay. mm,
Okay, can you explain?
Okay, so when the binary search tree is not balanced, like it only has one branch uh from the top to the bottom, and totally a number of elements is n. And when I traverse this binary search tree, is memory complexity is on, um, because I only had to iterate the one branch. But when it's balanced the binary search tree, I only had to think about the depth of the binary search tree. It should be login.
Okay, I have checked the code. Uh, I want you to make it instead of this global variable max. I need you to return the result in some BFS or max some BFS without
Mm,
uh yeah without this global variable max.
okay,
Can you do
just
it?
remove this one, right?
Yeah, yeah. I want you to remove the maximum and make the function itself return the result.
I see. Let's see. Question.
Uh, I can
Mm,
help you. Just it looks like you got the idea correct. You can simply have two variables, one for left and one for right.
already.
Yeah, that's gonna make your life easier.
I'm thinking. I don't know if I should write in this way.
Sorry?
I'm thinking about. Do you think it's correct if I solve it in this way? I just add a variable. It's called current sum, and every time we return this variable and remove the max. This one. Yeah,
Oh, you have
and
also
every
some.
some,
Uh,
but some is a parameter.
yeah, I actually want you to remove that too.
I remove this one.
Some.
Oh,
Yeah.
okay.
So the sum is gonna be your function. The function is gonna return the sum.
Okay. Oh yeah, yeah. I think it's yes, so it's not correct. Actually, if I write this, the return is current sum and remove this one. You mean add a left and right?
Uh, well, that makes it easier, in
Okay.
my opinion.
Let me see. Mm, okay, I think I What do you think about this solution?
Okay.
So I just thinking about, because this problem is find the max sum nodes in, but I have to return the sum nodes, right? I have to return.
Yeah.
Not just asking me to return a some name value, is how to return the elements.
No. Just the sum. Just the value.
But it said it to find the max sum nodes. Okay, I think it's just
Yeah, max sum of nodes.
okay.
I'm sorry if it's confusing.
Yeah, that's why I use that way to storage all of the elements, because I thought I should return all of the nodes.
Oh, okay. I'm sorry. No, you
It's
don't have to
fine.
do. Well, but it's a good exercise anyway.
Say again?
I said it's a good exercise anyway. If you
Okay.
did it, then that's pretty good. That's very good.
Eh,
Okay, so what you need? Can I? Okay, I'm gonna ask for control again. Okay, so you do max of left, right? But you're missing a parenthesis here, right?
yeah.
So this can be something like what I meant by having left is like this,
Mhm.
and here.
But what's the difference? Do you think it would initialize more memory if we write to
It's not a
instance?
big deal, not a big deal, but it's gonna help you to make the code more readable, you know.
Okay,
So what you do, then max left right, especially that you're still learning. We're all still learning, you know, but when you're beginning to learn these stuff, try to make it easier as much as you can, and this
okay.
helps. So max left right plus root val. Yes, that's the result.
Mm,
And
yeah.
here you return the result instead of
Yeah, but
this.
do you think actually I don't need to like write it? It's not should called BFS. It's like DF. So.
Whatever.
Okay, but do you think I can also um realize this um similar solution using recursion instead of use DFS? So what
This is
in your
actually
point,
recurring.
what's the difference between recursion and DFS?
This is DFS, not BFS, by the way.
Yeah,
BFS is
I
breadth first.
mm.
Uh,
But I want to
BFS.
ask you, what's the difference between recursion and DFS? Because sometimes I saw some people solve this kind of question, just write all of the code in the first function. Like they write all the code in the first max sum, use recursion, and just call this function by itself many times, just like DFS. But when I write DFS, I had to write another function and call the DFS function. But what's the difference?
You can do the same. I mean, even for this index, you don't need the index actually. All you need is this
Okay.
because everything is stored in root left and root right. So you can pretty much.
I see. You know why I need the index is because I thought this question is how to print out
Yeah, yeah.
every node. But
It's
if I have to
mhm.
print out every node, I have to use the index.
Yeah, yeah,
Right?
no problem, no problem. Yeah, but well done. This is correct. Okay. Very good. We're pretty much done. Um, write a recursive function.
Yeah, what was the difference? Actually, this question make me very confused. And because yeah, I saw if they just write the recursion function, just call the first one like find max sum, they
Mm-hmm.
can also solve this problem. But sometimes I just feel the recursion function is very hard to understand because it's hard for me to analyze uh, the process of the recursion. But if I write the DFS function, I still can know what happened every time. Yeah,
It's
so what's the difference?
when you get comfortable with recursive functions. I think that you will always go with recursive functions because they're always not easier, but once you master them, once you're not afraid of dealing with recursive functions, you're gonna always go and use them because they are easier to implement once you understand them well.
Okay, okay, I see.
And mhm,
Do you think the reviewer would ask me to write different solutions? Like, okay,
maybe,
okay, I see.
not sure, but maybe, yeah.
Mm,
But for you, it's important to know all the different methods because um, what you need to know is the thought process behind each solution, not the solution itself. This is what problem solving is for. It's to learn how to solve problems, not to memorize problems and recite
mm,
them when the interviewer asks you to do it. See?
I see. Yeah. I
Yeah.
know what you mean. But yeah, but I think both important. To remember the solution is also important.
Once you
Remember,
understand it, you don't have to remember it like by heart.
okay, but like the BFS, if I never solve this kind of BFS question, I don't know how to write the queue or mm, or how to iterate the tree. So
Yeah.
I think I have to remember how they realize the BFS. Then I can make some practice like how to use BFS solve this all kinds of problem.
Jink, what you have
Mm.
used is DFS, not BFS.
Yeah, I know that this is DFS, but I'm talking about if I wanted to learn like a new solution using BFS.
Oh, I see, I see. Yeah, we will come to that. We have exercises. There's a set of exercises about DFS and
Okay.
BFS.
Mm.
Yeah, we're getting close. So next set of problems is the dynamic programming list, and then the graph
Okay.
list.
And what? And what?
Mm-hmm.
I didn't catch your last sentence. You
Yeah,
said
I said we are coming to graph problems. So we're almost done with recursive problems. After this, we will do a bunch of dynamic programming problems, and then
okay.
we will go to the graph list of problems.
Okay, I see.
Okay?
Okay. Before next session, I
Mm-hmm.
can do some practice of that file, that doc file.
Okay.
Okay.
So please try to finish everything try to finish the whole recursive list functions because this is done. We have done this already. So please do it, and I need you to fill these with explanations. Of course, I don't want O of n. I want y, like here. Why is it O of n? I know that you understand it, but I need you to write it. It's important that you explain stuff by writing them down. It's gonna help you understand them better. You see?
Okay, okay, I see, I see.
Yeah.
Mm, do you have any tips can give me for my like coding interview?
Practice, trust me, it's all about practice. For example, this session, I think you did very well. This session, you answered most of the questions, and even if you didn't answer, I was guiding you, and you knew how to find the answers by yourself. I think this is your best session so far. By far, this is the best session that I've had with you, and I'm
No, what
being very
I had
honest.
to schedule me in the morning because in the morning I will be more and you know, probably because this reason.
I'm sorry, I didn't hear you very well.
Oh, okay. So I said probably we should schedule meeting in my Pacific time because in the morning I will be more energetic.
Oh,
And
cool, cool.
yeah, previously most time I schedule meeting with you is afternoon like 3 p.m. I pretty sleepy at that time.
Okay. Right after lunch, yeah, I get sleepy personally also.
Okay.
Okay, cool. Do you have any questions?
Uh, no.
Okay. So what you have to do for next session is finish everything, the whole list, okay? Please finish with these explanations and stuff,
Mm.
and write down the code for the last problem, 7, 8, 9, and 10, and start the dynamic programming list, okay?
Uh, okay. Mm.
Yeah.
Good.
Okay, I think I'm done from my end.
Mm. Me too.
Okay, cool. So see you in the next session. So as usual, you have my. But one thing, Jing, can
Mm.
you use? Do you have my other links for 1 hour and a half and 2 hours? Because if you book for hour and a half and 2 hours, it's gonna help me, know better, like schedule better. Because the previous time, like for so many times, we schedule for 1 hour, but we stay for an hour and a half, sometimes 2 hours.
Uh, what do you mean? You mean I use the schedule meeting with you?
Yeah, I have a lot of links. I have 1 hour and a half link, 2 hours link. I'm
Okay,
sending them to you.
you can send me a new one.
Yeah, yeah. Well, I send you the whole links, and you can choose from there.
Okay.
Okay. I have to go right now. I'll send you in a message. Well, we did 2 hours minus quarter,
Mm.
so you can send me whenever you're free.
Okay. You mean next time I schedule meeting, choose like a 2 hour session or choose uh 2 1 hour session.
Um, did you see the message that I sent you on Code Mentor?
I do.
There I have the links.
Okay. Let's see. Oh, okay. Got it.
Yeah. And
Mm,
I have many links there. You can choose how long the session, the one you want it to be, and then book from there. Okay.
okay.
Okay. Cool. I have to go right now. Talk to you soon.
Mm. Talk to you soon. Have a good weekend.
Thank you. Have a good weekend, you too.
Mm. Thank
All right.
you.
Bye, Jane.